Hi friends, let us discuss construction of Turing machine for 2's complement of binary number. The task is to construct a Turing machine for finding 2's complement of binary number. To get the 2's complement of binary number, you calculate the 1's complement of binary number by inverting zeros into 1's and 1's into zeros. Then you add 1 to the LSB, that is least significant bit of the 1's complement of the given input. For example, the input contains 1 0 1 0 0. You find the 1's complement of this input, that is 0 1 0 1 1. Then you add 1 to the LSB of the 1's complement of the given input. So if you add 1 with this bit 1, output will be 1 0. So put 0 here, then 1 will be a carry. Then that 1 will be added with this 1. So again it will get 1 0. So you put 0 here, then carry 1. That carry 1 will be added with this 0. So you will get 1 here. And this 1 will be taken as it is. This 0 will be taken as it is. So this is the 2's complement of the given input. Let us try to find the shortcut method to derive the output from the input without going through the usual process of finding 1's complement, then adding 1 to the LSB. You observe the pattern between this input and the output. Till the first one, the input symbols are same in the output also. So after that first one, the bits are inverted, that is 0 becomes 1 and 1 becomes 0. Let us try to find the solution by applying the shortcut method what we have discussed now. First step is start from the left. Then move right without making any change until it reaches blank. Now move left from blank till it reaches the first one, because we have already discussed that till the first one there is no change in the bits of input and output. Then you move one step left and make zeros to ones and ones to zeros. Now repeat the step 4 until it reaches blank symbol in the left. Let us see the construction of Turing machine for finding 2's complement of binary number. Q0 is the initial state. In the initial state, if we find 0, keep it as 0, move right. If we find 1, you keep it as 1, move right. That means we have to reach the right end of the input. So when you find a blank, you keep it as blank, then move left and reach the state Q1. That means now we are at the right end of the input. So from the right end of the input, we are moving left, and if you find 0, you keep it as 0, again you move left. But when you find the first one, you keep it as 1, then move left, reach the state Q2. Now, after finding the first one, you make all ones as zeros and move left, and zeros means make it as 1, then move left till you find the blank symbol. Once you find the blank symbol, that means we have reached the left end of the input. Then keep the blank as it is and stay there, and we are reaching the state Q3, that is the final state. In the transition table, this arrow indicates Q0 is the initial state. If Q0 finds 1, it will keep 1 as it is and move right, and again you come back to Q0 state. If it finds a 0, then 0 will be kept as 0 and move right, again you will be in Q0 state itself. But when it finds a blank, it goes to Q1 state, the blank will be kept as it is and move left. Then Q1 state, that is here. So if you find a 1, it will go to the Q2 state and move left. But if you find a 0, it will be kept as it is and again you come back to Q1 and move left. But blank symbol is not applicable for this Q1. And Q2, that is this state where you make if it is 1, you make it as 0 and come back to Q2 state, then move left. If there is a 0, you make it as 1 and move left. Again, you will be in Q2 state. But when you find a blank, that means you keep the blank as it is, you reach the state Q3. Q3 is the final state. The instantaneous description for this Turing machine, you can see it here. We have taken the sample input 1011 and Q0 is the initial state. So when Q0 reads 1 or 0, it moves to the right and comes back to Q0 state because we have to reach the end of the input. So that is what happening here. When Q0 finds a 1, it won't make any change but move right. Again Q0 finds a 0, it won't make any change, move right. Q0 finds 1, no change, move right. Again Q0 finds 1, then move right. So we have reached the right end. After reaching right end, when Q0 reads a blank symbol, it goes to Q1 state. When Q1 finds the first one in the left, it won't make any change. It goes to the Q2 state. When Q2 finds 1 in the left, it will make it as 0, then move left. Again Q2 finds a 0, it will make it as 1, then move left. Again Q2 finds 1, it will make it as 0, it will move left. So finally Q2 finds a blank symbol, it goes to Q3 state, that is the final state. Now we have obtained the 2's complement of 1011, that is the final answer is 0101.